Delivery point automation provides the next big savings potential in mail processing. Siemens' innovative escort-based delivery point automation concept represents such a solution for bundling letters, flats, and residual mail per delivery point in a very efficient, automatic way, by using one escort per item. What does the ultra-simple escort-based solution look like? Isn't it just load the escorts, simply store and sequence the escorts, and unload the escorts again? This is exactly what this concept stands for. Let's follow how the multiple block diagram functions are realized by subsystems. Feeding and loading. This happens within the infeed and loading section. Transporting and storing. This is done within simple transport tracks and storage towers. Sequencing. This is realized within the cascade towers by diversions only. Unloading the escorts. This is done within the extraction station, followed by the containerization as the last step of the process chain. Let's take a detailed look at this concept, starting with the infeed and loading section. The small escorts are loaded from the left side and aligned at the right side of the escorts. The items of the 3 delivery points are allocated to 3 different colors and are traced in the following through the system. In contrast to the small items, the large escorts are loaded horizontally after locating the escorts in an appropriate position. To realize the appropriate position of the escorts that is needed, they're moving in an S-shaped movement. Downstream of each loader, the full escorts get merged into one transport stream, shown as a growing gray line, marked with the colored indicated items. Let's follow the indicated items on their way to the storage tower. By diverting the escorts to the right storage tower and to the right level with 3 lanes, the first sorting step with a sorting depth of 36 takes place. The storage tower is filled continuously over several hours. This process takes place at all levels, but is shown here only for the 3 tracks of the upper level. Each level carries 4 carrier routes. Entering the storage tower, the gaps between the escorts are closed, and the consolidated escort stream is transported in sections into the escort tower. Reaching the cutoff time, the escorts are sequenced while being continuously transported to the extraction station via a cascade tower. By passing a matrix, the 4 carrier routes per level get separated into 1 stream each, thereby increasing the sort depth up to 144. Let's focus on one carrier route which contains the colored items, and let's see how the sequence task gets done within the allocated cascade tower. The escorts enter the first cascade on the upper level and are diverted into the intermediate buffer line underneath, providing a sort depth of 28. Diversions are shown only for the colored items. According to the movement of the last escort, the intermediate buffer line is emptied into the dispatch line underneath. Afterwards, the dispatch line is emptied while the escorts are transported through the U-turn to the upper level of the second cascade. The escorts are diverted again into the intermediate buffer, now creating sequenced mail volumes of the delivery points. The additional sort depth of 28 provides 784 for the cascade process and results in almost 113,000 DPs for the total system. Per cascade tower, 2 carrier routes can be sequenced simultaneously, only by simple diversions. Now, the last step: extraction and containerization. The sequenced carrier routes are directed to the corresponding extraction station. To align the escort cutouts, the small escorts are lowered before all escorts get unloaded by one stroke, gripping and pulling the mail out. After the containerization of the mail stack of the adapted length created in this way, the complete filled containers are transported to the tray management system. The different orientation of large and small items is adapted to an efficient delivery process. To finish the whole process, the empty escorts are transported back to their storage tower by passing through the cascade tower on specific tracks in the middle plane. That's all. It's that simple. The basic system presented so far is the smallest fully functional system. All machines currently needed for sorting processes of letters and flats are highlighted in blue. The first step of migration is to take out approximately 8 DBCSs and implement one basic system of an Escort Cascade sorter. The extension to a full-blown system can be done stepwise in increments of one or multiple basic systems, according to the needs of the customer. The full-blown system shown with 6 basic systems represents a nationwide average size for P&D seats. With this final configuration of the Escort Cascade system, the one feed, one touch, and one platform features are realized, as well as the main goal to get single DP bundles in sequence. Let's summarize the main features and advantages. Escort-based system unifies handling. Small footprint due to high storage density. Flexible and reasonable migration. Sequencing by diversions only. Low velocities due to lateral transport.